Good afternoon, and thanks for joining us for this presentation. We are TCCA, we are partnering association with EENA, and these two sessions will be ours. The TCCA, I will tell you a bit later more about the association. We are about critical communications, and we strongly believe that there is no any success in any of the jobs that have been mentioned here without successful communication. So we're going to talk about communications. Since we are intending to mention a number of times term critical communications, and also we're going to talk about open standards, I suggest that we tell you what is our view or our definition of critical communications. So of course, critical communications is always and can be everything that is critical, meaning when someone calls 112, it's really critical for him to get it. But here we talk about secure radio communications, which are vital for performing some tasks, functioning of an agency or completing a mission. There is a lot of discussion about this division to mission and business critical communications. It's just here to let you know that it's not just public safety. There are some other things that are also dependent on communications. For example, air traffic or manufacturing of oil and gas or things like this. So there is a nice definition which is almost correct, meaning that mission critical communication saves lives and business critical communication saves money. But if there is, for example, explosion in the power plant of gas, then this mission critical becomes, this business critical communication they use becomes mission critical. The point is that it's all technology, all way of functioning, everything is same, so this is just to know what does exist. Of course, it can be analog, digital, historically, it can be voice only, data only, voice plus data. Then you will see it can be narrowband communication, just the radios, it can be wideband communication with enhanced data capabilities of radios, and it can be broadband, which we are going to talk mostly during this presentation. It must be resilient, reliable, and provide recovery functioning. It must be redundant and must be robust. And what are the open standards? Everybody can make standards. Any group of people can make standards. The question is who can use them and how can use the standards. Open standards are standards made as a result of collaborative process of interested parties. So they sit together and they make standard, and then the point of open standards is that they are open, they are available. So whoever downloads, reads the standard, theoretically should be able to make something according to these standards. This enhances competition, improves the quality, gives much bigger offer of possible products and solutions. So this is why we advocate in TCCA open standards. ETSI is a European Technology Standards Institute. That's an organization that makes open standards which are well known, among the others, DECT or TETRA for communication, and participates in 3GPP standards like GSM 3G and of course 4G and 5G standards. We support them, we cooperate with them. We are probably the oldest partner of ETSI in supporting development and usage of open standards. In that way, we catalyze multi-other markets worldwide, and also, it's another thing, we try to advocate harmonized spectrum. Wherever a dedicated spectrum is used for radio, we try to advocate that it should be harmonized throughout the countries to enable cross-border cooperation and cooperation of the units in Europe and wider. Our members are end users, operators. Here we have 4 of us who are there. You will see we have representative of industry, representative of operator. We have the represented independent consultant here as a member. Our colleague from Airbus will join us for panel discussion, also our member. So it will be, we try in our work to work collaboratively, to work across the complete critical communication ecosystem to find the solutions that will be good for everybody and beneficial for the users of critical communications. We inform, advise, influence. We are 3GPP market representation partner. 3GPP is a body that works of standardization and other participants that work together on creating the global standards. One of them is 4G and then another one is 5G. You'll hear more about it later. We also facilitate maintenance and development and enhancement of the ETSI Tetra standard, which is probably the most successful. It was one-time success of a radio system used for critical communication that is still used today, and we predict will be still used in at least 10 years from now. And we organize events. One of them is 1 month from now in Madrid, Critical Communication World, which you are all invited to join and to enjoy. Our members have access to knowledge, opportunity to participate, opportunity to influence developments in critical communications, to participate in our events, to meet people, to learn, to participate in conferences, in trainings which we organize, and of course through web, social media, print channels, to promote their activities, update and so on. And that's it about us. That's TCCA. Without further ado, I'm going to give the floor to Tero Pesonen, who is Vice Chair of the Association. By the way, my name is Mladen Vratonjic. I'm Chairman of the Board of the Association. Tero Pesonen is a Vice Chair, and he's going to talk about the road to broadband, broadband status, migration to broadband, and of course, which probably interests very much you here about control rooms in light of broadband and the new critical communications systems. So, Tero.
Thank you, Mladen.
Here you go.
So, right, let's go to the road to the broadband. Start a little bit with the history. The first generation, obviously, the analog technology and analog trunking technology. The second generation, the great difference was digitalization and an ability to basically have clear voice, encryption, and moving into a whole generation of different capabilities. But something in common here between the first and the second generation. Most of all, they were narrowband technologies, so fairly limited amount of bits per kilohertz. And secondly, they are very much voice focused. Although in the second generation, Tetra and others, you can do a whole lot of messaging. And with those, obviously, marvelous, wonderful applications, but nevertheless, in a limited fashion. Whereas then when we move to the fourth generation, now we are talking about data. Now we are talking about information-centric operations. And that's the major difference here. That's the revolution. Obviously, you notice that there isn't such thing as third generation here. And that's what we have done on purpose. Because if we look at the second generation, the narrowband, even Tetra enhanced data service, that correlates more with GPRS on second generation. So we in the industry, we basically skipped the third generation and went straight to fourth generation on the, most of all at the moment, largely as a complementary broadband, but more and more in the mission critical LTE 5G. Let us have a look more on this transition and what those elements are that are required. First of all, you need to have the technology in place. This technology development we do obviously in standardization in 3GPP, where we are a major party. But once the standard is there, then it needs to be implemented. We need to have the commitment from the industry to actually fulfill and produce these things. In TCCA, we can be quite happy that the major industry partners are actually our members. Say Nokia, Ericsson, Huawei, and others are there. And they are also the ones that make the most contributions in standardization to this sector. So when you meet any of those people, say thank you. They're doing a lot of work in a sector which is still a fairly limited part of their business. But they do it because they believe in stable societies. They believe that once societies are successful, once people are safe, then the rest of their business is also okay. If consumers are in trouble, their business is in trouble. Obviously, in order for the transition to really take place, you need to have multi-vendor market. Multi-vendor market requires interoperability and certification. Those are things I will touch a little bit more later during this presentation, because those are challenges where we need to work together to make sure that they happen. The second element is the environment. And that's an area where we all have a lot of things to influence. Now the question is, for each country, what is the legal and regulatory situation? Can mission critical services be rolled out in the first place? In my country, I'm from Finland. I'm here on the mandate of Erillisverkot, the Finnish public safety operator. We recognized a few years back that we won't get any dedicated spectrum. So if we wanted to do it ourselves, we wouldn't have any space. Secondly, the law didn't dictate anything how one would do it in a shared spectrum or shared RAN, radio access network, with the consumers. So we had to start with a fairly significant legislation process to establish this and make sure that it's in place. Took us for a few years. So I really would like to recommend you to have a look at your national legislation. What is the situation there? Secondly, what is the operational model? Is it a service which is bought from somebody like in UK? It is a service provided by Motorola and EE. In US, it's a service provided by AT&T. In the Finnish case, the core network is provided by us, a public safety, government-owned public safety operator, whereas the access is bought as a service from a commercial mobile network operator. So that's another important question. What is the operational model? And then, of course, related is how it is to be financed. And a whole lot of more of those things, how to do implementation, rollout, upgrade cycle. What is the availability? Do you need to do hardening on the networks? Currently, mostly the dedicated networks, there has been a degree of hardening done for the base stations in case power isn't there, for instance. Whereas as we are currently actually conducting a European-wide study, what is the regulation on availability of commercial and mission-critical networks? In our country, at this very moment, commercial networks availability has been set to 3 hours. If power is gone, after 3 hours the base station is gone as well. And if we are using the commercial base station, then all the services for public safety are also gone. So that's another area where we obviously need to work together in the society to make it work. So this was the second big element for preparing the transition. But then the third one, I would say, is probably the most important, and that's the users. And most of all there, the trust and commitment of the users to do this transition. Now, for the users on the field, they need to trust their life on these communication systems. So the question is, can I do that? Can I trust the new technology? Can I trust the provider? Can I not trust the service? Does it work end to end? And I must say it's far from easy to deploy. We are doing it now in Finland for a few years, and our plan is and target is to have it operational in 23-24 for people to start shifting from Tetra to broadband service. This year we are starting right now delivering data-only capabilities to see and build trust on the user side, that they see that their data applications work wherever they are. And this shall lead to a situation that the users also update their standard operating procedures from the analog or from the narrowband Tetra versions to utilize the information-centric way of communicating in broadband. I remember back in the early part of this millennium, when we did the previous change, it was rather frustrating when the network was there. Tetra was providing coverage and service, and then some of the agencies woke up and said, yeah, but we can't start using it because we haven't updated our procedures. Hang on, wait another year and then we'll be there. Obviously from taxpayer point of view it was a bit unfortunate because then we were obviously financing two systems. So take every effort working with the users together to build the environment and then proving the technology. If we look at the actual top-level broadband roadmap now, most of all for public safety, public protection and disaster relief area, the time until now has been most of all about standardization, implementation of the standards, some first movers, most of all in the Persian Gulf area, where one can basically make decisions by sheikh's will and have some means for financing as well. Most of our dedicated networks, there we are seeing that the technology as such works. And now, at the very moment, obviously standardization continues. But it's more in Europe, most of all on regulation. It's about concept building. How do we benefit from these data capabilities? What do we do in order to be more safe, be more efficient, and enable the society to stay safe in this changing world? How we see the rest of the decade is, again, about standardization. The technology is dead when the standardization ends. So basically, that will continue forever. But we are expecting also to see wide rollouts, service intake in many places, and gradual shift from the voice-centric ways of working, which were defined mainly in the 70s, to this next generation way of working, and into the new operational models. If we put it on a timeline, we can see that a managed window for transition has just recently opened with the maturing of the technology. On the other side, we see that Tetrapol, they continue to be available for beyond the foreseeable future. So they will serve just fine. And if you have narrowband spectrum, if your needs are basically voice and messaging, wonderful technologies. But if you need to have video, if you need to have massive data, then obviously narrowband technologies cannot do it, at least alone. So the window is now open. What we see in Europe also is the other end of the window when it closes. And that's basically the time when in most nations, Tetra and Tetrapol base stations come to their technical end of life. So they basically start falling apart. And by that time, one would have had to move to utilize broadband, have the new services in place. Otherwise, one needs to reinvest into the narrowband technology, and that is obviously a financial burden. If we look at the railway sector, they have even worse situation because the industry has announced that GSM-R will be obsolete in the end of this current decade. So they can't even reinvest, it's just gone. So they have a really a challenging time now ahead, in particular as they tend to make fairly slow movements. If we look at what we are doing about this, On one of the things is that we see in Europe and elsewhere projects taking up. In Belgium, they have chosen the model. New Zealand is now in procurement process. Australia is testing concepts. Switzerland, they just sent out recently a request for information. In Finland, we are in the middle of device procurement. And these are just news from the last, I would say, 2 months, 3 months. On TCCI side, we have a bunch of task forces working on these topics. We just released the 5G for critical communication white paper to bring a bit more understanding what 5G means for this sector. We have another white paper on 450 megahertz, 400 megahertz area to communicate on what kind of spectrum things are related, what things are happening in that part of the sector, most of all for dedicated networks. And then we are just launching a white paper on a mission-critical broadband device procurement to help out to see a difference how to procure devices in broadband era. Devices that may have a life cycle of maybe 3 years compared to the devices we are used to in mission-critical side, which might be 10 to 15 years. And how to do it in a way that one stays on top of the game. At the same time, we are closing finalization with broadband applications, mission-critical broadband applications. Tim, maybe you mention a word about that, since he's leading the task force. We are also working on devices application interface in order to enable sustainable ways to manage applications. And a whole lot of new task forces we are launching in addressing those things that our membership brings up as part of their projects. Typically, the problems and challenges are the same everywhere. So these are what we are addressing there. In addition, we have a whole lot of cooperation with ETSI, working towards ability to certify broadband devices, to have multi-vendor market, to ensure that if you buy from this or that, they actually work together. Like you have it in Tetra, and like you have it as a consumer, but to have it also in broadband era. And on this one, we have also a presentation later on today on integration to control rooms. Harald will be speaking more on that. On my side, the part which takes most of my time is actually 3GPP Release 18 prioritization. So that's the newest thing which is happening there. And here, just quickly, I'll show you what we are, how we are bringing the sector and vertical into the minds of other people in 3GPP. So first we start there to remind them what mission-critical services are all about. What are our core requirements? Basically need to be able to serve the society everywhere, at all times. It needs to be available in sunny days as well as in catastrophes. It has to have the performance to enable the incident to be solved, be it small or large. It has to have the scalability for that, and the functions actually need to be fit for purpose, because the connection is really the lifeline here. Without connection, there's really nothing. And as a result, I'm not going really into this list, but as a result, we are trying to impact a whole array of features in order to push those earlier requirements forward. And I must say that we can be very thankful. This has been taken very well by parties that have absolutely nothing to do with public safety, but they understand that they want their children to be safe. They want their societies to be safe. So we get to advance these in many ways. At the same time, of course, it's our job to try to help them to find consumer business uses for these same cases, so that it makes sense to implement them as well. And with this, I'd like to say we will be continuing this discussion quite strongly in critical communication world, now starting in early November. bringing the whole society together, whole vertical together there, including a control room masterclass. Maybe Harald, you'll mention more about that in your presentation. So I'd like to invite you all there also to bring your needs and push your thoughts for the community to take care. With this, I'll bring this presentation to summary. So 3 takeaways. Narrowband, such as Tetra, will serve fine. It's great technology, will continue to be there for a long time. However, it can only do voice and messaging. If you need more, if you need to be data-centric, you need to move on. The national PPDR critical 4G, 5G transition, that's happening in Europe most of all during this decade. I would say it's happening worldwide during this decade. So it's time to make the environment in your nation ready so that you are in the same boat. With this was the first presentation
The first
of mine.
and you continue now with the other.
Yeah, I can continue.
Do you want to take the questions now, or we are going to take the questions?
I would like to actually take, for this I'd like to take questions now, because the other one is more a teaser on another topic to push your mind maybe.
So, dear colleagues, the floor is open. Can we have some questions related to Tero's presentation, or to TCCA, or critical communications in general?
Do you want to replace GSMR?
Sorry?
GSM for railways.
Yeah.
What technology will replace that?
Our expectation, well, there are 2 streams. One stream in 3GPP SA6 is to enable 4G to be able to serve that, but UIC, the organization, is mainly driving for 5G to replace GSMR, and they're also working strongly to get additional spectrum to be able to have dedicated 5G for railways, and that spectrum process is working fairly well. In release 18, one new feature will have to be introduced, and that is to enable less than 5 megahertz channels for 5G, because otherwise you can't fit it in. But currently there is fairly positive industry support for it. From public safety side, we wish to support this as well, because on band 31 there is 2 times 3 megahertz spectrum currently free, which cannot be used because we don't have proper channels for it, in particular for 5G. So from public safety point of view, if railways get that, then we also get technology to utilize the other spectrum. Personally, I am in all for sharing. So I would like every nation also to think that, hey, how about we share resources, and with that build them harder and have more capacity in place. But that's not TCCA view, that's strongly my personal view.
No, not far from TCCA view,
Yeah.
of course.
Other comments, points?
And please introduce yourself when asked the question. Here we have Beck.
Hi, Martin Walsh from the Garda, Economy Ireland. How many additional base stations do you require over and above what's available in Tetra at the moment to roll out the higher speeds?
That is a very good question. So you can basically, I suppose the rule of thumb is you double the frequency, you double the amount of base stations, you double double the bandwidth, you double the amount of base stations. So for instance, for Finnish case, we have in Tetra we have more or less 1,400 base stations. Finland as a country is about the size of Germany. However, our population is 10% or something. So that's the comparison. But now, as we have chosen to use the radio access network from a commercial operator, we automatically get thousands of base stations because they're already there. Where though this has an impact, if each of them have to have battery backups for, say, 3 days, it's a significant investment. So that's probably not going to happen, but we need to find alternative solutions there. But we have a commitment that the coverage will be the same. Our current coverage with the public safety network is 97% of the geography, 99.99 of the population. And we will get the same from 4G, 5G, however it will take a couple of years to do that.
Yeah, there is always a rule that with commercial operators they cover the population and critical communications operators cover the territory, because you never know what's going to happen where.
Yeah.
And the second point, which if it was not completely clear, except Middle East, where they have money to build their own networks, dedicated networks for public safety, the future seems like that public safety or critical communications features will be implemented in public operator networks with necessary enhancement, improving of coverage, additional transmitters and things like this. But per the future looks like that it will be the same, one network, because it's too expensive and too inefficient appears to everybody build their own networks.
Having said this, they are obviously, 450 band is fairly low, so there you get a lot of coverage. And it seems that in societies we are moving more to critical IoT services as well. And one would probably need solutions where you don't have all the eggs in the same basket. So future will tell what the balance is, but I would expect that at least now we are experimenting very strongly in many nations with the cooperation of shared networks. Core is everywhere dedicated, but then the radio access side is many times shared and obviously needs effort to be proven trustworthy, coming back to the user's trust question.
Well, we have more opportunity to talk during the panel at the end.
Yeah.
So feel free to ask any questions at the end of presentations you are interested in. Also feel free to bring your friends and colleagues from outside. I think that some of them are making mistakes who are not here, but never mind. Tero, can I ask you to give another presentation now?
Yeah. This would be more. This is more a teaser and lead into the following presentations. So the topic here is role of control rooms. And you see the question mark because I trust that you know more about this than I do. So let's be clear about that. What we see here as prevailing trends is that we have a shift from many to one, from fixed to mobile, from voice to information, and from silo to cooperation. And now, with these teaser sentences, I'd like you to think, what does this mean to control rooms, and then challenge my colleagues in the next presentation. Feel happy to give them really hard time. I mean, that's just fine. Right, if you look from many to one, we used to have many emergency numbers, now we have 112. We used to have separate emergency response centers per geography as well as per jurisdiction, but those are becoming more and more common virtualized solutions. In Finland, it's actually just one for all. And in this Corona time, COVID time, it was absolutely wonderful that if you had exposure in one place, the whole country could be taken care by another location because the system was the same. All the resources were the same, and all the resources were serving all the different jurisdictions, taking all the calls regardless of the case. Obviously horrible, but at the same time brilliant. We have had the tradition of having separate consumer and public safety communication networks. Tetra is dedicated, has had to be, because there was no way to be able to make the commercial network perform. Well, that's changing now. We are making every effort to prove that right. Moving into shared services. We have had multiple technologies, just Tetrapol, DMR, P25, and a bunch of others, and now we are moving in all 3GPP technologies into one train. It's a fast train, so we need to really keep up with it, but it's a common standard technology. Moving on, from fixed to mobile, commanding capability is coming everywhere. This is a vehicle from the Finnish police. Their view is that every police vehicle is also a police station. Anything you can do at the station, you can do in the vehicle. You have all the data there. Also, commanding happens on the field. Commanders do not actually sit in control room, they are there on the field. With that, we get one patrol more and save some facilities. In fact, there's discussion that the police stations might be just rooms in the back of a shopping mall with the showers and lockers, because the people are being served by these. In most of all in the countryside, you might actually call the police to come to you instead of taking a day off from work and travel somewhere 300 kilometers, queue in a place, deal with some gun license for 5 minutes and then come back. Technology enables. From voice to information. Now with citizens to ERC, in the other room we are hearing about the NG112 in Switzerland. Voice, location, real-time text, photos, and so on, sensors. But also from ERC to field and from field to ERC. Massive amount of data. There our questions are, how do we handle this? What is the commanding processes? Previous presentation in this room actually gave us some pointers on that, pretty good ones. But these are the questions to you. How to handle that? We have few task forces on the area, but that's the area. Then from silo to cooperation. We have used to have each jurisdiction working on themselves. Well, how about to have them all together? This is what we actually have today in Finland. We have these guys, and then the customs. They have a deal that they can have inter-exchangeable jobs. So the emergency response center can send a customs person to a police task if the customs person happens to be closest, or vice versa, or border guard. And in particular in the countryside, we have a bunch of border guard there since we have a long border to Russia. They are many times the first and only responders in the area. It gives a whole lot of efficiency, but obviously they need to have access to information, they need to know, and they need to have the skills. But it's not only that, it's also then the transport, the utilities, all those things that give the society working. Moving from silo to cooperation. So, my question for you is, what is the role of control rooms when the trends push from many to one, from fixed to mobile, from voice to information, and from silo to cooperation? And from here, I trust Tim will take on and provide some views what are happening.
Before you think of starting answering the questions Tero asked you, I suggest that we also listen to Tim Clark, who is going to tell us more about control rooms and about a special, completely different field, that's something we did not have before in critical communication, that's applications. Something similar to everyday's world, Play Store and other things, and something totally different with absolutely different approach, that's applications in broadband. With this, I want to thank you, Tero. Thank you very much. It was very interesting. And to invite Tim Clark, board member of TCCA, to present about applications and control rooms. Thanks.
Great, thank you very much. You've put me under pressure now, Tero, so thanks for that. I'll see you later in the bar. So, good afternoon. My name is Tim Clark. I work for Motorola Solutions, but I'm talking to you today in my capacity as a board member for TCCA. I'm based in the UK, so I must say it is great to actually come out and, despite COVID and despite Brexit, to be actually meet people and see people face to face. I'm going to talk very, very briefly about how broadband mobile applications, both on the citizen side and on the public safety side, have implications on the control room and how those control rooms, emergency response centres, PSAPs, how they need to evolve as those applications are used. So let's have a quick look. This diagram shows, in very, very simple terms, the two spheres. Okay, so starting off with the top, I think it's needless for me to say that we all use mobile broadband data applications in our daily lives, some more than others. For my teenage daughters, it seems to be a 24/7 thing, but even I use them. Even I use them for booking travel, for navigation, for video calling, for gathering and sharing information, and more for doing my day-to-day work. So that's why you've seen presentations throughout these 2 days, how the PSAPs, the emergency response centres, are having to evolve to be able to communicate with citizens, not just in traditional voice, but also with video and data, and utilise location data to get the best possible response for those citizens in trouble. So, as I say, you've all heard about the Next Generation 112 initiatives and the different solutions that are available to enable that communication, that response to happen more quickly, more effectively, and ultimately safer and to protect lives. Now, on the public safety side, within the public safety organizations, you've also heard from Tero and from Mladen that applications are being used by first responders today. Police, fire, ambulance, they're using applications today, but typically over commercial networks. And as those data applications become more critical to the operation of those agencies, they're having to look at how they make that network, that system, mission critical. And you heard all about here before, that's taking, in most cases, that mission critical broadband network will be based upon commercial networks, but they need to be hardened. They need to be made more resilient. They need to be made more secure. They need to extend the coverage. And that's what many, practically all public safety organizations and operators are either doing or planning for today, is planning and deploying those mission critical broadband networks. Now, voice is, and probably always will be, the best means of communication in time-critical, urgent, quickly evolving situations. Voice will remain the optimum communication tool. But those data applications are becoming more important, more critical as the days go by. So, as Tero was saying, there's a real move now to make those mission-critical broadband networks as resilient, the same coverage as Tetra systems today. Tetra will continue, as you heard, for the next 10, 15 years. In some cases in parallel, in some cases it'll be superseded, and it changes on a country-by-country needs kind of basis. So this mission-critical network, as it's rolled out, will provide near real-time, seamless, high-capacity data connectivity between the control room, the first responders, and a whole network of what I've called here public safety IoT, or the Internet of Things. And that could be, as you see here, it could be drones. We've heard a lot during the past few days about drones and how drones will become over time the first responders to go out, get pictures, grab video, get information, get that situational awareness back to the people first responders who are on their way to the event or to the incident. It's also about command and control of devices, public alerting. There's a big focus on public alerting, particularly in the light of the floods across Germany and Belgium. How do we ensure that the citizens are aware of events as they happen or before they happen. And that's something, again, where mission-critical broadband can play a part in terms of enabling high-density IoT types of application. Also, video, and you'll see video on all three bubbles here. There's video on buildings, there's video on vehicles, there's video on citizens' doorbells, there's video worn by the first responders. And all that video information, great information, but there's a lot of data, there's massive data to handle and make sense of and turn that data into actionable intelligence back at the control room. There's data coming in from, as you can see here, from a first responder, a policeman, an ambulance, a emergency medical person, a fireman becomes a personal area network of many different sensors. Sensors that are monitoring their heartbeat. They're monitoring dangerous substances in the environment. There's a sensor on the policeman's weapons, so when the weapon is drawn, there's automatic notification back into the control room. There's sensors if his stab vest becomes penetrated, for example. So all that data is coming back to give real-time contextual awareness back at the control room, but there is a lot of data to manage. And that's really where this comes into play, what I call here intelligent assistance. That really is artificial intelligence. Now, artificial intelligence has to be used properly, in the right place, in the right way. I think there's a lot of concern whenever people mention artificial intelligence. There's concerns, there's fears that robots are going to take over the world and replace people. That's not what artificial intelligence is and how it should be used properly. I'll talk a little bit more about that in just a moment. This is an example of an application within a PSAP for handling this omni-channel communication from citizens. So you can see here that typically an emergency call is still initiated via a voice call from a mobile phone or from a landline, but that can be augmented with additional information from the phone on the mobile device, from the doorbell on the resident's house, from CCTV around the area. So if the call taker feels it's appropriate, they can enable the citizen to provide data into the system that gets built into the call record, and that becomes evidence, it becomes a record for assessing quality and response times and all those good metrics. And that is automatically built into the call detail record, which can be stored on site or up in the cloud is often the way, but the cloud is a whole topic on its own. And also the call taker can benefit from artificial intelligence in terms of smart transcription, and I'll talk about that in just a moment. Just jumping back again to artificial intelligence and how it should be used properly, and again, it is a massive subject, and there's a lot of talk about it today, how it should be used ethically and properly. And I think these are the three bullets that really stand out to me that I've heard from various people. There's this guy, Randall Davis, a professor at MIT in the US. He's well known as a well-known expert in AI and how it should be used properly. And I think that one of the most important things is AI needs to assist the human. It's not to replace them. It gives them, it turns all that data into actionable intelligence that they can then use to make decisions. Humans are typically very bad at doing repetitive, boring tasks. If you sit a control room operator in front of one screen, it's not so bad. If you put them in front of 12 screens, it's very difficult for them to track what's going on, and in a matter of minutes, they've lost interest. And it's very, very difficult to identify issues as they happen. So let the AI handle that. Let the AI, the intelligent assistants, let that detect if there's a potential problem and alert the call taker, the control room operative, to that potential incident. Also, it's very important to keep the intelligent assistance clear and concise in what its role is and how easy it is to verify. It might be difficult to assess all those millions of cameras that are kind of keeping track of what's happening in the city. But it needs to be very clear to the operator, yeah, that looks like a fire, or yeah, that looks like there's been an incident on this road. So the verification needs to be quick and simple to be useful to the end user. And also, of course, keep the human in the loop. That's absolutely critical. Don't let the AI make the decisions. The AI provides that intelligence for the human to make the decision. As I say, massive topic, and maybe we can come back to it later in the panel session. So just jumping back to that smart transcription, this is again an example of an application that's available, which as the call is received at the PSAP by the call taker, there's AI, there's artificial intelligence within the application that can transcribe the conversation as it comes through and then start to do smart stuff in terms of if it picks up on particular keywords, if it picks up on repeated locations, it may give better information as to where the incident is happening. And it also guides the call taker based on what's being said. It suggests keywords and follow-up questions and prompts that the call taker can make. Again, it's all about trying to reduce the stress on those call takers. We've heard that during the time of COVID and now in hopefully a post-COVID world, those stress levels are not going to get any less. So anything that we can do to help those call takers and make them work more effective, more efficient, is going to be better for all of us. There's also been a big focus on video analytics. And again, using smart cameras, using smart analytical applications to alert the control room humans to potential issues. For example, and also to help them find information and find real intelligence. So there's appearance search, for example. You can go back through video archives and find out where a particular individual was, where they moved through a building, what they did they drop a bag somewhere, did they speak to somebody else? You can use that information. Again, has to be used ethically and always keep the human in the loop, but a very, very powerful tool. Unusual motion detection. That can, again, if you've got millions of cameras over the city, and all of a sudden one of them picks up that there's a plume of smoke, a potential plume of smoke in an area that hasn't been seen before, that may be a problem. The smart camera alerts the operator. They take a look at it and say, no, it's just a tree moving in the wind, or, yeah, that looks like a plume of smoke. We'll get somebody out there to look at it. Same thing with object detection. In this case, it's a little bit obvious. It's 3 guys with high-power assault rifles. You know, these could be bags that have been dropped. And again, it all comes back to the operator to say, yay or nay, that's somebody with a scaffold pole, or it could be, yes, that is somebody with a gun. We should get someone to look at it. And then again, unusual activity detection, smart cameras can learn what typically happens in any one location. So if, for example, a vehicle is moving on the wrong side of the road in the wrong direction, or they're parked in an area they shouldn't be, again, raise the alarm automatically to get someone to look at it. So these are just some examples of the smart stuff that's available today. And it can innovate very, very quickly. You probably all saw examples of this, that within weeks of COVID and lockdowns, there were video analytic tools available to track whether masks were being worn, to measure social distancing, to automatically raise the alarm to operators if things weren't being done properly. And again, it's keeping the human in the loop, but it's being able to sift through all that data and turn it into action. So that pretty much brings me to the end of my very, very brief presentation. And again, behind all this, behind productivity and safety and protection for the citizens, that mobile critical communication network is an essential part of the story. So thank you very much.
Thank you, Tim. You may ask if you want questions now, or you can save your questions for the end of the round 2, where we will have the panel. And the panel is not just for us to talk about what we have already told, but for you to ask the questions and we to try to answer your questions. So if this will be the case, I now inform you that there is a coffee break at halls 1 and 2, and after the coffee break, you may have a choice. The obvious choice will be to come here and to continue, I hope, to talk with us and about these topics. But if you find this boring or you are interested in some other stuff, track 3 is that's us. Track 1 is session on location in next generation emergency communications. It's in plenary in room Omega, and then there is a track 2. Which is going to be in room Alpha, emergency communications handling around the world. So I hope to see you all, and perhaps more of you, in half an hour here in 25 minutes before 5, we are going to continue with this session. Thank you very much for joining. Hello, thanks. Oh well, I now have this one. I don't need to come here. Thanks for coming back and for joining us. Now I will give the floor now to Harold Ludwig, who is head of our technical forum in TCCA, and he is an expert in testing. He runs the well-known interoperability process, which is something we established a long time ago for testing and of Tetra systems and compatibilities of Tetra system. So he's going to talk about a few things. First, about control rooms implementers guide. This is something TCCA was working as a document who should help organizations who want to implement control rooms in broadband environment. Of course, we did it in cooperation with many our members. And next, afterwards, Harold is going to talk about how it looks like to test applications in the broadband environment, which is, you will see, something completely different compared to the way we did it so far. So, but he's the one who has a say, not me. So, Harold, floor is yours.
Okay, thank you, Mladen. Okay, I think this is the last session for today, is it? No? Yes, yeah, okay. Good, I will first, as Mladen said, talk about the control room implementers guide. So with the rollout of broadband networks in many countries, there's also the question now how to connect control rooms to these broadband networks. I will focus on the connection of the control room to the mission-critical network side. So not the NG111 or the call taker for the emergency calls, but the communication to the first responders in the field. What we have now in many countries as a setup is this is a control room connected to a Tetra network or connected to a P25 network or a Tetrapol network, basically all the same, because we don't have any standardized interface for this connection, unfortunately. So there are only proprietary solutions, and all the Tetra infrastructure vendors have their own proprietary API where you can connect the control room. With the mission-critical broadband network now, you can either switch to mission-critical LTE, so switch off the connection to Tetra, switch to mission-critical LTE, or you can maintain both connections for the transition period. So then your control room can talk with the Tetra users, and your control room can also talk with the mission-critical broadband users. The question now here is, how does this interface look like? And this was a question many have asked. It's a little bit a better situation than in the narrowband market. This interface to the control room is covered by the 3GPP mission-critical standards. So even if the control room is not explicitly mentioned in the standards, or just a very few times, you can interpret the 3GPP mission-critical standards in a way that you can say, I can connect the control room. The challenge here is that there are several possibilities you can read out of the standard how to connect this control room to a mission-critical broadband system. And the question is now, which of these options should the control room implement, and which of the options should the mission-critical server side implement? Yeah? And are there advantages, disadvantages of these different options? So this question came up some time ago. And in TCCA, we organized a control room workshop, 23rd of January 2020, one of our last events where we could meet face-to-face. And this was really a big meeting because really not expected. We had 65 participants in Berlin that was hosted by BD-Boss. That's the German public safety operator of the Tetra network there. And we had even participants coming from the United States over to Europe to participate here. We had some input papers. We have minutes of this workshop. We have conclusions of this workshop. All these documents are publicly available at the TCCA website. What we agreed in this workshop in the end is to produce a control room implementer's guide to help all the involved stakeholders to see how, or well, what would be the best or the recommended solution to connect a control room with a mission-critical broadband network. You cannot write such a guide with 65 people, so we decided to form a small group, and this small group was working since the workshop to draft this guide. We finalized the first draft, which went through members' inquiry, so we sent it out to all members and all participants of the workshop for commenting, and we got back a lot of comments, and currently we are resolving all these comments, updating the guide, and this guide will be published on the TCCA website, hopefully in the next couple of weeks or months. We will see how fast we can do this. What's the content of this guide? So this guide first describes the current narrowband services and applications which are available in the control room. So, for example, you can do a group communication, a group call. You can do an individual private call in the control room. You can change the group members and things like this. And it also describes how to map these current available services in the control room to broadband services. Because we expect that in the beginning, the control room should more or less provide the same services as it's currently providing with narrowband systems. And in the future, these services in the control room will be amended by all the new nice features and functionality you can do with broadband, like video communications, like secure data communications, and so on. The guide also lists all the applicable 3GPP standards. If you're familiar with 3GPP, you know that one 3GPP release is about 1,200 documents. So we identified those documents, and this is less than, I think, 20 documents, which are relevant for connecting a control room. We are focusing on 3GPP release 16 because release 16 gives some of the features we need for connecting a control room. And at the moment it's for 4G LTE systems only, and 5G will be included in a later release if there are any changes necessary for 5G. Yeah? And the guide gives some recommendations how to connect this control room to the MCX server. That's the mission critical server, the network element in your mission critical system environment solution, which is responsible for setting up all these connections. Yeah. And in the end, we also identify some gaps and fields for further study. So we could not really find a recommendation for all the questions we had. And maybe some standardization will be necessary. Maybe some further work will be necessary to fill these gaps in the future. What are the benefits of this guide? If you have a common approach how to connect the control room with a mission-critical broadband system, then this reduces the number of connection variants. So currently in a control room, you have to implement an interface to a Tetra network vendor from vendor A, to a Tetra network from vendor B, to a Tetra network from vendor C. And all these interfaces need to be maintained, need to be upgraded maybe, need to be, if there's additional functionality, you need to make new software releases for them. So with a common approach, you really reduce the number of variants, and this also will drive the prices down, which is a benefit for the users. But the benefit for the control vendors is also that they have less costs for maintaining all these different connection variants. The target audience for this guide is basically architects and designers, so the ones really implementing the connections on the control room side and on the mission-critical server side, but also the ones who want to purchase control rooms, So operators, users, because they can use this guide as a reference for their tenders, for the tender specifications. Very important, if you want a common interface, you have to ask for it. It will not come just by appearing. So you need to drive your suppliers, your vendors, point them to the guide, say this is the interface we want to implement, this is the interface we want to buy, and if you write this in your tenders, then hopefully all the suppliers, all the vendors of the mission critical servers will start to implement it, and also the control room vendors will start to implement it. Tero already mentioned in the session before the coffee break, we will have a control room masterclass on the 3rd of November as part of the Critical Communications World. This is half a day workshop style session where we have presentations from different people, first telling us their experiences with connecting control rooms to broadband systems. So for example, in UK with the Emergency Services Network, we have some first experiences how to connect this. And the second part of the masterclass will be to highlight the opportunities you have with a broadband system connected to your control rooms. So what else can you do in addition to the current way of working, current services in the control room? Okay. That was the first presentation. Should I continue with the second one, or do you want to take questions?
The second one is a little bit different than this one. So if anybody wants to ask any question, not to forget listening to the second presentation, you may do it now, or make a note and we can talk when we sit in a panel here. Yeah. We intend to invite you to come closer so we all sit together and talk. Let's see what can be interesting for us. Okay? So you'll continue with your second presentation.
Okay, good. So as Mladen said, TCCA is involved or is doing Tetra conformance testing, interoperability testing for I think a little bit more than 20 years now. So we established this Tetra interoperability testing 20 years ago. And this was one of the success factors for Tetra. It really enabled the multi-vendor market. And now, for some years, we're also looking how we can, or what do we need to do in the broadband ecosystem to also give the users confidence that the products they buy are really interoperable and really conformant to the standard. As an introduction, I'll just highlight there are different types of testing. So we can have conformance testing, which is to ensure that your implementation, so if you implement something according to the standard, that your implementation conforms to the standard or to a reference implementation. Then we have interoperability testing, which ensures that two or more implementations of the standard work with each other, so are interoperable. And then we have performance testing. This is to ensure that your implementation under test meets some key performance indicators, KPIs. This can be the call setup delay or the voice quality or the battery lifetime. So these are the different types of testing. What are we doing with Tetra today is, or what we see in Tetra is that hardware and software are very closely tied together. If you buy a Tetra terminal, you buy the hardware with the firmware, software, everything together. You can do software updates, but it has to come from the vendor you bought the terminal. The same is with the Tetra network infrastructure. You buy the hardware with the software from one vendor. So which simplifies the testing, because then we only need to test the network with the terminal. We're doing this testing and certification. Currently, we do manual testing of about 1,000 test cases. Manual testing because there is no Tetra conformance test set available on the market. The reason is that the market is too small for the test set vendors. They did not see a business case to implement conformance tests. And all this testing is witnessed by an independent third party, the name ISCOM, and they are issuing a certificate if everything is conformant. So what we are doing is interoperability testing plus checking of conformance testing together. So this is a combination of the first two types of testing. So interoperability between the SWIMI, that's the network from one vendor with the terminal of another vendor. And by testing, we also take the log files of the messages which are going across their interface. And these messages then are inspected by the certification body compared to the Tetra interoperability profiles and standards. And if everything is okay, they issue the certificate. So quite simple in Tetra. In broadband, it's a little bit more complex because we have a more fragmented ecosystem. I don't have a radio terminal, I have a device with an operating system, with an application. And all these three may come from different suppliers, from different vendors. The same on the server side. You have a mission-critical server. In your LT network, you have different network elements with different software, different capabilities from different vendors. So it's not testing the network from one vendor with the terminal from another vendor. So you have a really complex setup with many vendors involved if you really want to test everything. Yeah? And control rooms. I mean, we have not really, I have to admit that our focus is at the moment not on control rooms. I will come back to this. We can test, or it's already, control rooms are already tested. But we would welcome if there are any user side, any users using control rooms, that you please come to us, join us, because we need your input, that we know what are your requirements, criteria for testing and certifying control rooms. So that will help us to identify what we need to do, maybe something in addition for the control room. So Tero mentioned multi-vendor environment, but we have also a multi-operator environment, which we don't have really in Tetra. So the Tetra networks are more or less islands. Some of them are connected, but not many. But with broadband, we expect that all the networks will be connected with each other at some point of time. And you can do testing in a lab, you can testing with simulators, and you can do live network testing. So another complexity level, different types of testing. What we agreed is that we will do separation of testing. Not like in Tetra, we do interoperability and conformance testing together, we will separate this. So we will do conformance testing, and we will do interoperability testing. So the conformance testing is where we work together with GCF, the Global Certification Forum. We have a work stream in GCF for mission-critical services. Some mission-critical conformance testers are under development. We have a similar issue like in Tetra, that the interest is not so high to develop a mission-critical test set, but at least 3 testers are available on the market soon. And then this will enable GCF certification of mission-critical devices. Yeah. Control rooms is currently not part of GCF testing, but we are in dialogue with GCF. Maybe in the future we can convince them to also include control rooms in their testing and certification. For the interoperability testing, we started some years ago the plug tests together with ETSI. So ETSI has organized mission-critical plug tests. And the next phase is what we plan for the future is, the moment we are very focused on the device side, on the application side. The next phase is also the server-server testing. If you connect mission-critical networks together, the servers, you need to do some testing there as well. And also the interworking with narrowband systems. You want to connect the broadband system with a Tetra system, you also need to test this connection somehow. What do we have today? Today we have from 3GPP conformance tests in some specifications. There's a task force 160 developing TTCN3 code, so program code for these test cases. You can implement this code on your test equipment, on your LT simulator. Then we have a GCF work item for MCPTT, which just needs to be activated once a test equipment is available. And then we can certify mission-critical products, mission-critical devices. There's a second route, which is also possible, because these LT simulators are very expensive devices. But the mission-critical client application itself is just using a connection. So we have also the route to use an IP simulator for testing this mission critical client. So this is for the conformance testing, and for the interoperability testing, we're currently having this ETSI plug test, where we have a document with test cases and observer scenarios, and doing these plug tests on a regular basis. Plug test is just an opportunity for the vendors to test with each other. There's no certification from these plug tests. We started with this plug test in 2017, and we are just organizing the MCX number 6 plug test, which will be held in November in Malaga, and also remote, so vendors can connect via VPN connections with each other and do the testing remotely as well. Okay, I think there was one slide missing, but yeah. So the documentation from these plug tests are also publicly available. These are, for each plug test you have a report, and you find this report on the ETSI website. Okay. Thank you.
Thank you, Harald. Thank you very much. I know that the audience enjoyed, especially this slide when you mentioned FT160 and these groups, you know, but I believe that the takeaway of this presentation is that, first, it's not simple. It's really, there are many things that have to be, that attention has to be paid when we are switching from narrowband to broadband critical communication systems. And the second takeaway should be that we at TCCA really try to cover the complete area to engage the possible institutions, to put them all together in order to something so important as mission critical communications is put on good foundations, and that in the future it will work and provide opportunities and benefits for the user much bigger and much larger than current narrowband communication. I see that something is wrong. Losing air. Thank you very much, Harald. Okay. If you want to ask something, or leave it to the end. And now, as the final presentation, I wanted to say a few words about what's behind the corner. And we all talk now already a lot about 5G and future critical communications. And let's see what is it all about, and for how long we're going to wait for this, and is it really something that can be reusable that can be usable for critical communication? And what about people who are just transiting to 4G? Are they making a mistake? Should they wait for 5G or continue their transition? We'll try to put a bit more light in next 10 minutes. Right, so what is 5G? It's the 5th generation technology standard for mobile telephone networks. It's apparently being developed by 3GPP. Should be 5GPP, but 3GPP is the old title used for previous networks, like as the word says, they develop 3G and they develop also 4G. All these development are based on International Telecommunication Union recommendations. And current recommendations on which 5G is working, are developing 5G is IMT 2020. This third generation partnership project is an organization that translates those recommendations and specifications by ITU to standards and technology, as it did with previous versions. Despite the large number of new functions and really structural differences and some very new technological solutions, 5G technology is considered essentially as an evolution of 4G. And it will be deployed in many different architectural models depending how time is progressing and how and when a certain component of the technology are available so that they can be used. what can we expect from 5G? This is a ITU spiderweb diagram that if you go axis by axis, you will see the differences. For example, a data rate of 10 megabits per second experienced will be up to 100 megabits per second. Spectrum efficiency will be better 3 times than in the 4G network. Mobility, which is interesting, can be up to 500 kilometers per hour. Perhaps answer to the question about railways. That's why Tero said some consider waiting for 5G. And latency, due to the flat architecture and some processing which is done remotely, closer to the user, it's expected that it can go down to 1 millisecond. And connection density, number of devices per kilometer, which is also seriously important when we talk about Internet of Things and sensors and all the things, is going to be much higher, up to, I don't know, million devices on a square kilometer. And of course, network energy efficiency. The devices will be more economic, the batteries will last longer, and also area traffic capacity could go up to megabits per second per square meter. Everybody talks about this, but if you remember, the similar talks were going on with 3G networks and with 4G networks, and will continue probably, and we are now facing similar problems related to COVID vaccinations and related to other different illusions that are circulating around. So simply, you see in this diagram, you see where the 5G frequencies are. The lower part of this 5G box are the 4G frequencies that are being used, the left part. So still far, far, far away from dangerous ionizing radiation, the one which breaks the atoms and molecules. Then, furthermore, higher frequency radio waves have weaker ability to penetrate. Then the use of more transmitters, as will be for the 5G, because the higher the frequency, the lower the range, then you have to use more transmitters. That means that each of them will be using less power. So there are any medical evidence that 5G is harmful for the environment. And I like to put this slide because all those waves that are going around. What should be the pillars of 5G? What can we expect as the users, from user perspective? Enhanced mobile broadband. In other words, faster and better and more reliable connection. Massive machine type communications. That's about what we call Internet of Things. So ability for much more machines, for much more devices without human interference to communicate without problems and with much higher density than it is possible now. And this one to the lower right is interesting also for critical communications, which is ultra reliable and low latency communication, which should find its applications in many many different cases, like self-driving cars and drones, remote commands, and I will come back later on to some examples of applications that can utilize 5G connectivity. You can see also on this map symbolically what should be the applications related to one of these three features, and this diagram is also from International Telecommunication Union. Here it is a little bit explanation. Enhanced mobile broadband, but I've already said you this. ultra-reliable and low latency communications targets 1 millisecond latency and 5/9 of reliability, which is something that is not currently possible to achieve with 4G systems. So this is key to support mission-critical applications, such as industrial internet, smart grids, but also from a medical point of view, remote surgeries, and also some intelligent transportation systems and many, many other applications. So let's go a little bit to dreaming about the future, but not exactly dreaming, because it is behind the corner. Eh? So if we combine enhanced mobile broadband with massive machine type communications, we can enhance data speed by even 100 times more, and also increase the number of devices connected per square kilometer. So, for example, connecting body-worn cameras and cameras in police cars to command centers to identify what is happening at an incident and to gain an overview of situation as it is going on, as it unfolds. Also, hundreds of thousands of different sensors. It was mentioned before in one presentation where everything from smoke, explosion, moving things, raising temperature, whatever is needed can be recognized, and then by use of artificial intelligence correctly interpreted and provide information. We talk about quantities of data that is transferred, but we should actually start thinking about information. And this is the artificial intelligence systems and other systems that will convert this bunch of data into useful information that can be used later on for people who work with artificial intelligence system to undertake needed actions. Famous drones, video surveillance and analytics. You can send drones where human cannot go. You can command them, communicate with them, and provide better awareness of urgent situations which are occurring somewhere that human being cannot easily access. With the introduction of 5G new radio and ultra-reliable and low latency communication, there will be much more applications. Some of them we even cannot imagine right now. When people ask me what drives the community, is it technology or people? And it's always a difficult question because you invent the needs and then try to make the technology that can follow your needs. But sometimes when you have the technology, the new ideas and new needs are invented based on available technology. So definitely many new applications will be used which we cannot think about them right now. This is reality. This was announced in the US, in the UK. Self-driving cars being tested on 200 miles public route. Can you imagine firemen with the glasses that can provide real-time augmented reality? So something using the communication network, it would be able for him to get in his glasses something that he is not able to see. For example, in a smoke environment full of smoke and full of dust, and he can get what is needed for him to perform corresponding action, but just using the reliable radio communications. Telemedicine, healthcare. Some patients will have constant monitoring of their vital signs and life signs, and also life habits. Yeah, it is, as we spoke in cybersecurity session today, it's a matter of how useful you considered sharing this information. Probably some patients who are in difficult conditions will gladly share this information 24 hours a day with their doctors so that the reaction can be in the moment when something is needed. They will not think about who else can access this information, or maybe this information can leak somewhere. So wherever you are using some devices, it's a trade-off between what you want, what you get, and what you may lose. And not to mention even surgeries. If you have low latency devices, you can do remote surgeries with robotic hands somewhere, or you can do a bit more simple real-time instruction giving to a surgeon who is doing the job somewhere in the field. This is, by the way, slide from Price Waterhouse. It's a slide about 5G and future healthcare. So, when it is going to be available, and are we going to wait? First standards are in 2020. Tero told us. Some first release equipment is already there, 2021, mostly marketing, because what you can buy as a 5G phones now, it is still in the LTE frequency bands working, and part of, as I said, it's the first step of evolution from LTE to 5G, what these things that are available now. Some real commercial deployments around 2025 can be expected. Now comes the question, are we going to wait for 5G? And the answer is no. First, 4G MCX. MCX stands for MC data, MCV, MC video, and MC voice. So this is, MCX is just X for everything. MC is mission critical. So standards for mission critical are 4G LTE are complete and are being implemented. And during the panel, we will talk a little bit about who is doing what in the world now, where, how is the situation, and what's going on. You all know the answer to the question, if you need a computer, are you going to wait for the new version, beta software, higher disk, or are you going to buy it immediately and use it? This is how it goes with 4G. So you go with 4G, and the transition will be paved from transition to 5G, from 4G to 5G by the technology itself. This is how it is work, how it is designed to work, and how it will work in the future. MCX standards will feed forward into 5G together with all these new applications that we still cannot dream of. So it might not be here tomorrow, but there is a little doubt that 5G is the long-term future. That would be all I have. The questions will come, I hope. And this is a small, nice photo of a beautiful city where we invite you to join us in beginning of November. It's the biggest world event. Again, like EENA, we made a break of more than 2 years after our last event. We had an online event last year, which was quite good, in fact, but it was online, and nothing can replace face-to-face meeting. I love to say that we can online do a lot of job, follow the agenda, and other things, but new ideas can only come up if we sit in the evening, order a glass of whiskey, and talk together, and then the new ideas can come, not online. So happy to see you all this time, and hope to continue to see you as it was before during the future events. Thank you very much for your attention. Now I invite my colleagues, and Philip too. Philip is here. Good. Philippe Ernaud is from Airbus. Airbus Defense and Space. But he is our member. Airbus Defense and Space is also a very well-known manufacturer of communications equipment for critical communications. So I invited him to join on this TCCA panel. It will be moderated by Tim. So I'm going just to join you somewhere, if I can use this chair.
Good. So, just while Mladen takes his seat, does anyone have any questions to kick off with? Anything that's from any of the sessions that we've had here this afternoon? Don't be shy.
You can come closer, of
You can
course.
also- yeah. Most of us won't bite. I'm not sure about Mladen, but most of us.
He's always hungry.
Yeah. No? Okay, well, just for such a scenario, I have some...
Maybe
There is a question.
Oh, yes.
One question. When do you expect will the infrastructureless communications between terminals meet the level and the coverage distances we are used to have from 2-meter analog and digital tetra and tetrapole in 5G?
Yeah.
5G or 4G or LTE, broadband.
You mean
Broadband.
broadband in general? Very good question.
Yeah, I have some data regarding to this.
So, I mean, as you say, today, often networking, D to D as it's defined within the 3GPP specs, is not sufficient for mission critical. Right? It hasn't got the range, it hasn't got the in-building penetration. So public safety organizations are having to look to alternative technologies, such as radio, such as using their tetra devices and frequencies, or using some other type of radio frequency. But there is work ongoing, and maybe you can talk about that as to how that will be enhanced in future releases.
Yeah, well, I wanted to say a few words about, for example, one of the implementers of broadband is FirstNet in the United States, and they have, according to their data, they have 90% coverage of band 14. They were lucky enough to get nationwide band of 700 megahertz, 20 megahertz within this band for their system, and they claim that they have finished 90% of coverage for band 14, and when they say that, they mean for critical communication, so it's enhanced coverage. It's not just an ordinary mobile telephony coverage, at least coverage as they requested that should be. For example, in the UK, you know also that in many spots, EE has increased the coverage of base stations according to the requirements of Home Office in order to provide. You can never. There are no digits that can provide and tell you what is satisfactory coverage for public safety, for example, because in 99% of time it will be fine, and then something will happen in an area, and then whatever you have, it will not be enough. This happens, but general guidelines, of course, exist, and requirements and history. I remember there was one police officer from Lancashire, I think, when they asked him about coverage, what would you like in your territory? I would love to have every spot of my territory covered by at least 2 base stations. That was if something happens to one, or if the capacity, or if there is a traffic problem, that the other one will work.
I think the question was about device-to-device communication.
Device to device, I didn't.
Yeah.
So you should,
maybe
you should remove the mask.
maybe
Device to device is a difficult thing. Yeah.
maybe I comment that. But part of what Mladen was saying here is quite valid as a response to that. Okay, in 3GPP we are working now on side-link-based proximity services to provide device-to-device communication. A lot of it has been specified in release 17, and now in release 18 we are working on gateways and repeaters with multi-hop and so on, with the target to be enable having full communication skills off network and on network with 3GPP technologies. Having said this, I think it's quite important to recognize that the world is also different, and the technologies are different. So we shouldn't try to look back and take everything from the history and have it mimicked in the future, but to look at the surroundings we have with the new technologies. Now with 3GPP technologies, most of all, what we have are multiple ways of providing connectivity. one is the base station, one is AIB, one is now we are working also on satellite connectivity, and we are working on the off-net network connectivity, and those jointly are to provide the connection that's always there, which is the lifeline. But it makes sense to seek for the solution, and the answer, the philosophical answer, is to have the connection. But from the first responder point of view, as long as the services work, it shouldn't really make big difference which connectivity is, as long as you don't have to pay much attention to it. But absolutely, really important part of work we are doing very much work on, and must say on the device to device. We will still need to wait for a while to see how the implementation will be.
Maybe we can say a few words about what happened in France. The MRI has issued a call for tender to have the equivalent of ESN. And for this coverage issue, in their minds, they have the view to have to get 2 MNO first. So with their solution, they will be capable to roam from one MNO to another one. So mechanically, it increases the coverage. And for this, when you enter into the building where you have no 4G coverage, whatever with any MNO, at the moment the solution, but it's a temporary solution probably, they have asked to the bidder to add another radio, like a Tetra radio, to provide direct mode connectivity when you have not the 4G coverage. That's
yeah. So I mean, I think the answer in short is there are different ways of achieving the same goals as what you could do in the past. Is essentially what we're saying. And if you take the example of the Faroe Islands, for example, there the coverage is so good that it was deemed that off-network was not so essential in the short term. So I think it really depends on the situation, and there are different options available to achieve that looking forward. And as you say, as we move to satellites as well, then that provides you that other layer of backup as well. So, yeah, yes, sir.
I totally second that. So, is it really device to device, or we talk about 4G, 5G, that the classical repeater we had it in analog is like our bubble. We bring the bubble. The bubble has a price of 5,000, 7,000 euros. So it's available already. So I can link my local cell there, as we had in the old analog times. We had a repeater on the car, which repeated back to us. So the way of thinking, what's this device to device, I completely agree with you. It must not be device to device in the real case. It can be like this local cell also. And this is only available in 4G, 5G. The other ones don't give us this option. Based on price.
It would be good if whoever asked removes the mask for the moment. for the sorry,
He just
I recognized you, Gregor, even with the mask, you know. But it's better if
he just agreed with Tero.
I already kicked 4 times by the girls today, so
Any other questions or topics? Normally, I get asked, really today, what is the real situation with the rollout of mission-critical broadband around the region, around the world? So, I mean, I think that Tero covered some of this earlier in his presentation, but maybe a little bit more of a deep dive, Mladen, into FirstNet in the US. What's happening there?
Oh, well, according to the, well, first in the States, they do it data only, so far. We can, it's different. It's a big difference. We have 2 pioneers. One is DSN here in the UK, and the other one is FirstNet. And the Koreans, Tero, I guess you can say a little bit more about what Koreans are doing. But in the US, 2 major things. They have their own frequencies, which is great, and then they are forcing data. There is no single radio network of local that has been switched off so far. And they will switch it off when they are happy and when they get the same and the more level, also voice features from the FirstNet. At the same time, they are making together with AT&T a huge data network, which according to their data, there were 17,000 agencies who have signed for the FirstNet who work right now, and it's more than 2.5 million daily connections, and it's something really, it works. And they have, we were talking about applications, they have the catalog of applications for the FirstNet, which is about 170 applications at this moment. And Monica, if you, did you want to say something also?
I was just going to say, in the U.S., just because the FirstNet broadband is going to be stood up, there is no expectation from public safety agencies that we're going to turn off the traditional radio networks, because what is a problem is in rural America, FirstNet is not working.
In rural America.
In rural, there's not enough infrastructure, and the FirstNet contract with AT&T, they have 25 years to build it out.
Mm-hmm,
So we do not see the other infrastructure ever being turned off.
At the
So
same,
they won't be able to reach it.
yeah. So it's about the coverage. At the same time, they dive deeply in MCPTT applications, trying to provide voice over broadband from different sources. But still, if there is no coverage, then it will definitely not work. And in the UK, but you know better, they will switch a narrow band sooner or later. It is expected to be in several years switched off. And in fact, that should be the real test and the real impression for the rest of the world, how they are doing with broadband. I don't know, Koreans, maybe you can update on Koreans.
Well, yes. SafeNet South Korea has now ended up the rollout phase, so basically coverage has been built, and they are now more or less in serious trialing. Obviously, that starts the migration, which will eventually take a few years, that's clear, before all the processes have been ironed out and worked. But the rollout is there, the network is there for public safety. There are some additional things going on for railways and for maritime, as it is actually a 3 networks, 3 cores sharing, 3 RANs. A rather complicated constellation, but it's happening.
And in many other countries, maybe we should mention.
Yep.
Yeah, I think
Up to a
it's
certain stage, yeah.
worth to mention the Middle East area, Persian Gulf. There are dedicated networks there, which has enabled them to start early, as you have full control of the resources. You don't need to share anything. So in terms of capacity, in terms of security, in terms of management, far more straightforward, and many of those are connected with the Tetra networks. Perhaps you'd like to.
No, you're right. Yes, we have this hybrid mode in the Middle East, in many countries. Yes. Maybe.
Finland, what's going on there?
Okay, sure.
Since the documentation was very promising, but
So sure, in Finland the situation is that the legislation is in place, contracts are in place, core network is by Ericsson, and is now installed. It's in final acceptance. The radio access network is from MNO Elisa. Elisa also in the acceptance level for the first phase. They are working on extending coverage, but already obviously from the beginning the population coverage is over 99%. And the geographical coverage is close to 90%, so it's available in most places. The time plan is that data services will be made available end of this year, so basically next year is the starting phase for mission critical preemptive priority data services, and the transition phase for MCPTT, well, PTT services starts soon after, with the intention that the majority of the users would have moved from Tetra to broadband by end of 25.
That means they bypassed FirstNet and the UK.
That,
Why would they bypass
that may and might be the situation. However, having said this, let's be modest and recognize that there are certainly a lot of issues to be tackled, things that we haven't thought of, but quite strongly there's a great commitment and trust jointly with the public safety operator as well as the user community to work together and address issues, identify things, and share and learn from others in order to be able to do it in a safe way. The commitment is that TETRA will work there as long as it's needed, and broadband will be great as soon as possible.
Maybe just a comment worth to mention that this is the first time in human history that the whole world agreed on one technology. And not only the whole world, but also across the sectors, public safety, railways, utilities. And I think this is a really great opportunity because it really scales as it drives up the scale.
I think you just touched on a very important point as well, is that beyond the technology, the users need to totally trust the system before they're going to use it. And I think that goes beyond the technology. That's education, that's showing alternatives, maybe don't think of how things were done in the past, but use the technology to do things differently into the future. And I think that's also been a key learning, particularly from ESN, and that openness and that engagement with the end users, make sure that end users' needs are fully understood, and then try and address them in whichever way makes sense. Good. Any more questions from the audience? How are we doing for time? I think we need to.
I think, is this valid, this timer that is ticking here?
4 more minutes.
Yep. 3 minutes, yeah.
These people want to get to the bar, I can tell.
Yeah.
A very interesting fact that you separated the testing, so no longer so it's software testing and the radio testing. What is the, and in the case of, what do the providers have to provide as part of the RAN? Is it bandwidth or is it, what's the cut-off criteria for supporting, and just in rural areas, away from the base station, is there a point where you fail? What's the cut-off point, say that you failed the test?
I mean, there are different types of testing. As I said, conformance testing, interoperability testing, you basically do this in the lab, but you have also live testing. And live testing means that you go out in the field with your device and test the service. And there will be specifications, test cases, which clearly identify what has to pass, that the test case passes. Yeah. In digital communication, it's quite easy. I mean, if you have a signal, if you can establish communication, you have communication. If the signal is not available, then you don't have communication. So.
I would say that is a really, actually rather relevant question. What is the service level you are to get at the designed cell edge? Mm-hmm. And the specs for that varies from country to country. So the expectation for good service differs from places to other. The minimum I have seen so far, which I said that this is way too low, was 256 kilobits. And I was like, okay, which applications, broadband applications, still work with that kind of speed? So, whereas then many say that, look, you need to get 5 megs up and 10 down, or something like that, and that obviously cumulates with the amount of users, the incident you have at the site. Yeah. So these are quite relevant questions, and I would like to say, maybe it's fair to say, the jury is out there. We'll see in
it's
real
not us.
real use cases then what will be required really to sort out the incidents.
Yep. Thanks.
The attenuator is a way. I think the final question can only be the practical experience in a best network. Because what is in the lab, what is in the figures has basically nothing to do with the experience of the people out there, what devices they have. And if they choose to have certain devices with a negative antenna gain, and they're out there, then suddenly everything you have calculated in the lab and designed in your theory.
Yeah, but this is again to a local, to every administration or every country user operator to set up, as Harald said, the performance indicators. So those who are
And it depends on many parameters. It depends on the service. If it's voice or video service makes it different. It depends how many other users in your cell together with you, how close these users to the cell, how close you are to the cell. So there's no constant service, you can say. It's
on the devices.
as well. No.
Performance is very poor typically
Yeah.
in public networks.
In our device procurement, the Finnish device procurement, we are asking for possibilities for external antennas in order to improve the reception. As we have a whole lot of rural areas in the nation, and the design difference between Tetra and broadband is that in broadband you actually do not really design overlapping cells because of interference, whereas in Tetra you generally design a whole lot of overlap. And because of this, you actually operate many times at the cell edge. And therefore the radio characteristics is an area, if you have a great specialist, it's probably worth paying the salary.
And you obviously touched on a very key point as well, which we probably don't have time for now, because I'm being told that time's up, but the devices is a big issue. The expectation that consumer off-the-shelf types of devices are going to be suitable for mission critical is not realistic, but that's a whole new topic. So any final, I think we've probably run out of time, but any final questions before we wrap it up?
Follow on. In the cases where you're using the public network to provide mission critical, what is the bandwidth you demand from the operators? What is the clause, or what is your demand from the cloud operators when you go to tender? What's normal in your industry?
So what's the bandwidth requirement that is recommended? I mean, of course, it depends on application and what you want to do with it. Guys, I mean, I know this is...
There have been some studies I've seen that for public safety, you need 2 times 10 megahertz. So uplink, downlink, 10 megahertz. We will see if this is sufficient.
I would agree with that. I mean, the studies that we've seen that have been done across very different groups, 10 to 15, that sort of number, to be used for real data applications as it's intended, that will generate the value for those users, 10 to 15 megs.
This is what FirstNet is having in band 14, 2 times 10, yeah?
So you're talking now about spectrum,
Yes.
right? In our case, what we required was everything on every technology. In our legislation, we set up that the MNO that provides the radio access service for public safety or mission critical users in Finland has to provide preemptive priority on every band they have, on every technology they have, from now until eternity, basically. So as long as there is capacity in the network, we can take it all.
We wish you to get it once you...
Well, we wish that we never need it.
Indeed, that's a good point. I think with this we can conclude this session. Thank you very much for joining us. I understand that you were here because you were really interested. Thank you for your questions. We have a booth here. Most of the time nobody is sitting there, but anyhow, there are the cards with our phone numbers and email addresses, and we are sitting sometime in our booth. So if you have other questions or interests, please join us and ask. If not, then write, and we will find time to answer to your questions. And third recommendation, whoever is not a member yet, please become a member. That's it.
Yes,
Thank
let's
you.
drive common challenges together to solution.
Sure. If you want to be part of the future and part of the history, join us.
Thank you.